You peel a banana this morning. You don't think about it. It's just breakfast. But the banana in your hand is a clone, not a metaphor. A literal genetic clone of every other banana like it on the planet. And that single fact might be the reason you'll never taste it again. Here's the strange part. This has already happened once. Before the 1950s, the banana you ate wasn't the one you eat today. It was called the Gros Michel. Sweeter, creamier, and by most accounts, better. It was the banana. Then a soil fungus called Fusarium oxysporum started moving through plantations in Central America. It didn't just weaken the crop, it ended it. By the 1960s, the Gros Michel was commercially extinct. Why did one fungus take down an entire fruit? Because bananas don't reproduce the way you think they do. They don't grow from seeds. Commercial bananas are sterile. Every plant is cut and replanted from the tissue of another plant. That means every banana of a given type is genetically identical to the next. No variation. No individual immune differences. If one plant can be killed by a disease, every plant can. The journalist Dan Keppel, who spent years researching the fruit's history, describes this as the banana's original sin. A monoculture built for shipping efficiency and shelf life, not survival. So the industry needed a replacement. They found one, the Cavendish, resistant to the fungus that had wiped out the Gros Michel. Bland by comparison, but tough. It became the banana. Over 99% of bananas exported worldwide today are Cavendish. Same clone, grown across Latin America, Asia, and Africa. Here's the twist. In the 1990s, plant pathologist Randy Plotz identified a new strain of that same fungus, Tropical Race 4. And Tropical Race 4 does not care that the Cavendish was supposed to be resistant. It kills Cavendish plants too. It has already spread through Asia, the Middle East, Africa, and Latin America. Once it's in the soil, it stays there. For decades. There is no cure. There is no treatment. You cannot spray it away. Sound familiar? It's the same story. Same fungus family. Same monoculture. Same vulnerability. Humanity solved the problem in the 1950s by finding a new clone. But a clone with no genetic diversity was never a solution. It was a delay. Geneticist Ronnie Swenin has spent decades studying wild banana relatives in search of natural resistance, arguing that the only real fix is genetic diversity the industry deliberately bred out decades ago. Somewhere in the jungles of Papua New Guinea and Southeast Asia, wild banana varieties carry genes that could resist Tropical Race 4. Most of them you will never see in a grocery store. They don't ship well. They bruise. They don't fit the crate. You've built a food system without realizing it that prizes uniformity over resilience. And it's not just bananas. Much of what fills a modern supermarket follows the same logic. The same strawberry, the same seedless grape, the same apple grown from cuttings, not seeds. Efficient, predictable, and identically vulnerable all at once to whatever eventually learns to beat it. Which brings you back to breakfast. The banana on your counter isn't a static, permanent thing. It's a fruit currently losing a fight it may not win. Replaceable only if humanity finds and breeds a version resilient enough to survive what's already spreading through the soil it grows in. The Gros Michel didn't disappear because bananas are fragile. It disappeared because humans optimized away its ability to adapt. So next time you peel one, it's worth asking, not whether bananas will always exist, but whether the version you know will still be here in 20 years. Because history has already told you what happens when an entire species puts all its survival into a single genetic copy. You just haven't been paying attention.